Okay, so we're going to get started. Thanks for joining us for today's webinar titled Using the Data That You Already Have to Find the Best Prospects. We're going to go 30, 40 minutes and then have time for a Q&A at the end, and this is being recorded, so you can, we'll let you know when it's posted within a week or so. So the premise of this topic is Advisor does fundraising analytics in healthcare, higher education, and not-for-profit, and we've seen many clients spend fortunes, literally fortunes, acquiring data, hiring consultants, building what we would call overly complicated models, and investing in hosted platforms when they already have most of what they need right at their fingertips. All that's required is a little bit of blending, some synthesizing, and some common sense. So that's the agenda for today's webinar. We're going to just sort of go through the steps of loading in data that you have, blending it together, doing some binning, synthesizing, calculations across tables, some modeling, and then pushing it out to a team in a usable way so the team can make better fundraising decisions. I'm Doug. I'm your host. I lead Advisor Solutions. We've been in the business intelligence sector for about 15 years. We're in other sectors or other parts of the market, manufacturing, cybersecurity, as well as fundraising. We've got a lot of data analytics experience, and we are a clear leader in fundraising analytics with over 250 clients, active clients right now. So for today, we are going through a process where we're going to look at framing the question or the questions that need to be answered. So in any kind of use of data, this is really important to nail down, what you're actually trying to do, what questions need to be answered, why you can't answer them today, and what form data could be useful for answering those questions. Then we're going to look at accessing data, blending it, which is connecting stuff from different tables together, synthesizing it, which, like if you look at employment, for example, we're going to look at this. Employment records by itself is interesting facts, especially when you get to an individual. But out of it, you can bin out on, say, title. We would call this synthesizing out of the employment C-level jobs. Now, C-level jobs can be a proxy for capacity, which is highly useful. So we're going to go through several different ways you can synthesize and get more content out of the data that's in your database tables. We're going to look at building a predictive model and how you can do that, and then combine all this together to push it out to a team so that they can make better decisions. And over on the right, an example of maybe from a health care fundraising client where there's a CRM system that's got events in it, which is useful for looking at recent engagement activities, giving history, which is useful for seeing what they've given, but also the frequency of they've been giving recently, which is predictive of step-ups and all of that. A bunch of biographical data. There's probably some wealth ratings in there. On the patient side, there's inpatient visits, from Epic or Cerner. There's a bunch of systems that track that. There's relationships, there's outpatient visits, there's biographic data. There's usually coding lists that describe what the codes in here actually mean. They all can be loaded into a platform like ours. We're a front-end, in-memory, light footprint data mart. There are other versions of this out there from some of our friends and competitors, but we like what we do, so we're using us as the example here. But the idea here is you pour the data into this light footprint front end. You might say then as you go along, we actually haven't wealth screened everybody. We need another proxy for wealth. So let's grab some public wealth code data. Maybe newsletter click-throughs helps us understand another measure of engagement. So let's bring that in because we want to understand recent interest in our messaging we've been putting out. And you can keep going. But the idea here is there's a variety of data that you have in different databases that could be easily brought together and used. So framing the question, we're just going to go through the agenda, topics, and sequence. You just got to identify what are you trying to do. Are you trying to find more large donors? Are you trying to figure out which marketing messages are best to acquire non-donors? Are you trying to help your fundraising officers be more effective in close rates at asking at more aggressive levels? Those are different problems, and you would maybe load the same data, but you would purpose it very differently for those three examples. What do you need to know? Trying to find, are my highest value prospects assigned out? You need to have some way of knowing what does highest value mean. What information do you have that might help you answer the question? Highest value could be wealth rating, so on the prior page. It might be I haven't well screened everybody. How else can I get some quick handle on that? Well, maybe I could look at, do they have a C-level job out of my employment data? That could be helpful. Do they live in a wealthy zip code? Because there's really good rankings of wealth in terms of both property values and income levels by zip code. That would help me answer it. So I could probably get my hands on that information. The other aspect of a great prospect is somebody who's also engaged. So what kinds of things that you have in your system somewhere that you can get your hands on is an expression of people's interest. Event attendance, clearly. Have they been giving recently? Clearly. Clicking on newsletters. Yep, they're telling me I'm interested in your newsletters. All that kind of stuff is there. And as you start thinking about the question, it has these different premises underneath and then different data that you could then use to help find the entities or the experiences or the feedback you need to make that decision better. And then the question is, what's getting in the way? Sometimes event attendance, the problem is it's not being collected systematically. Like the New York club collects it all the time. The San Francisco club doesn't. That's a fixable problem. It's a process problem. But if you actually need the data and there's a clear purpose why you need it, the team can make the decision. We need to take the practices from the Chicago club, the New York club, where they're actually, looking at the name tags that aren't taken and recording that so they know who actually came, and do the same thing in San Francisco. So those are all solvable problems. And as you go through this, you end up with, for this set of examples today, what factors might influence undergraduate alums to give, and who else has those characteristics. So getting this started right, we see so many teams jump into, like, they need a warehouse, they need a bunch of data, they need some charts. You actually want to have content that will help you address the questions that you need to answer. So then accessing data. Think through what you have. What else can you get? What else might matter and make a difference? And that just run through before on the questions. If you're not collecting event attendance systematically, that can be repaired. If you're sending out newsletters and not getting the click-throughs, the newsletter sender has the click-throughs, and they can be really useful at the entity level to look at engagement. So there's a set of these things that when you think through the problem, it starts working to help create solutions to the data, because there's a bunch of software tools like ours that if the data is in some electronic form, it doesn't all have to be the same. It could be some's in Excel, some's in your Razor's Edge SQL Server database, some sitting around in text files somewhere. That's all fine, but as long as it's electronically captured and somewhere on a network where you can load it. So then I'm just going to go through an example of what factors might influence undergraduate alums to give. Who else has those characteristics? Well, all of you have some kind of a core system, a CRM system, which has an entity table. The different systems call it different things, but it's entities. And it's got basic bio geo table. It's usually got wealth scores or ratings have been loaded in. It's got class year and affiliation if it's a school, which is what the example here is. You've got degrees. It's got a bunch of stuff on each of your entities. But what could be useful for answering this question is, do they have an advanced degree, an MBA, a JD, or an MD? That is proxies for higher wealth and would be useful to explore out and create a factor that you can then look at the entities around. Same thing with employment. Employment, a lot of our clients have partial employment, but with social media, there's more and more ways to get that much more systematically, and it's useful because you can parse out things like, do they have a high-level job? What's their field of work? Student activities, by itself, it's a bunch of stuff, but you can calculate out of it how many sports did they play, how many activities did they play, what were they? That starts becoming relevant for engagement or attachment. On the giving side, total gifts, but also like how many of the last 5 years did they actually make a gift? All of them? None of them? 2 of them? Those are different answers and very different expressions of current interest. 6 to 10 years out in maximum gift. For those of you in healthcare institutions, obviously this is higher ed focused. Patient encounters has a lot of the same stuff. We're finding it's extremely relevant which area they were in, how many times have they or a family member been in, what's the time between the first and the most recent visit, when was the most recent visit. There's all kinds of intensity and engagement that comes out of that. It's sort of like on the higher ed side, student activities and sports. That's creating a connection with the institution that then the advancement group builds on by running events and starting to get giving going. healthcare kind of works the same way. And if you just swap out student activities and sports for the healthcare experience, which is well categorized in encounters, you can do the same kind of thing. And we ran a webinar on this about a year ago, which is a pretty good run-through of that side of it. But for now, we're going to stay focused on higher ed. And there's other stuff, event attendance, which may or may not be in the course system. You don't care about all the events, but you want to look at like recency. In the last 5 years, how many events have they been to? 6 to 10 years back, which events? If events are important, I guarantee not all events are the same. Some are going to have more influence on connections, some less. So you can actually create modeling scores on the types of events and group them and look at frequency in those different time periods. Again, this is all information that can be synthesized out of an event attendance list. Volunteer committees, newsletter click-throughs. You don't care about all of them. You certainly care about recent ones. And here we've got numbers in the last 12 months. I'd probably cut that back to the last 2 months. Probably be more primary. And by what they're clicking on, they're telling you what they're interested in. If they keep clicking on science stuff, message them about science. If they keep clicking on football, sports, that's another thing. Reunion surveys, there's a lot you can get out of that. They're structured well. You can parse data out. And then social media, we've been finding this more useful for getting content on employment, volunteer participation in other areas, those kinds of things. And we're actually working with a number of vendors to try to figure out, who actually does this well. There's a lot of excitement there, but I would say for now what we're finding is the things at the top that you pretty much already have are paramount. But in our suggestions, you work through this data and you think through at this level in the context of answering the question. If you were doing this for looking at annual giving, non-donor acquisition, you'd have a different set of issues and probably want to look at some other data. You certainly want to bring in appeals. You want to look at which appeals have worked recently to help acquire non-donors. So there's other stuff you would bring in as you thought through that problem. But I went through this in some detail because we see people jump to the data, but we like to start with the question and the premises and then make sure the data has the content to answer the question or the premise. And then, in our world, in our tool, if you want to load data, build what we call a project. There's a set of steps. You load data, you design pages, you work with the data, create expressions. We're going to go through a lot of this. And you analyze data, then you share it out over the web or in PowerPoint or whatever you want to do with it. To load data, you would literally click on this thing, load new data, and it brings up a wizard. And you load in views or tables or views from different databases. You can load in a lot. This example, we loaded in, it looks like 10 tables. We typically run 10. In some cases, we might have 150 if the tables are very fragmented. This is a fairly small data set, 76 fields. That's a reasonable proxy for what most of you would typically have in the kind of work you can do. 1,000,006 rows, you can sort of see the spread. Looks like this set's 93,000 people, 1 million gifts, 100,000 event participations. There's a bunch of stuff in here. So this is the idea. This loads in, and then you have to blend it. So you get the data in, and then what we've done here is just shown lines because you have to affiliate the tables with each other to do calculations, to do selection links. You'll see all of this coming. But in our world, to connect the tables together, you click on something called cross-table links. So now we're blending. You get a wizard. There's a bunch of tools that do something like this. We kind of think we do it really well. You get a link wizard. You click next. It asks you what table, what kind of link do you want to create. Selection links allow you to select, you'll see this a bit later, say an entity and see their giving transactions. Or you could select a bunch of like $1 million gifts. You'll see which entities made the $1 million gifts. Or appeals, and you'll see which people got the appeals, and then from the giving, which people actually gave to the appeals. So this lets the data kind of work like a huge pivot table, and it's the primary thing that we do with the data after we've accessed it. We blend it with these selection links so it all works together. We can also copy fields from one table to another, and we can subset or roll up one table into another. So there's different kinds of links. You click next. It asks you, we're doing a selection link, what's the origin table, the entity table, ID. I click again. I want to link to the gift table on ID, and then it creates the links. And then when you're done, this is a typical data model for one of our not-for-profit clients. It's drawn by our tool. There's an entity table, a constituent table, and there's a bunch of other tables, financial transactions, Up here you've got different constituent group numbers. You've got board relationships, event registrations. You sort of see there's a whole set of content here that's come in from the tables that then by blending gets affiliated together with a collection of selection, copy, and aggregation links. So that's blending, and that's a fairly straightforward process. Now what happens is you get done and you say, well, I actually thought I had wealth ratings on more of my population than I did, so let's add in some other stuff. And the other stuff that we typically would add in would be wealth information, and there's a bunch of public information by zip code, so it's easy to do this. There's a variety of firms that do psychographic segmentation, so the data that you have would let you do behavioral segmentation. You know, people have come to events, they've done stuff, they've expressed interest, you know, all of that. There's another set of things on the raw characteristics of the people that create a propensity to give or not. And there's firms that have large consumer databases of people all over the country or the world, depends where you are, and who can create profiles of propensity to give outside of your institution. So this is just based on who they are as people, psychographic segmentations versus your behavioral segmentations. And then social media, the coolest things we've seen, and we're working with some partners on this, is getting the ability to get more widespread employment and volunteering data. And volunteering can be useful because if they're volunteering, say, for the Autism Association, and you're trying to do fundraisers on autism, that's a useful thing to know because that's presumably an interest area. So Wealthy Zips. If you want to load that in our world, there's a bunch of data. Is ranked by zip code. The top U.S. zip code, which we would group in the U.S. 100, is 10065. It's in New York. They've got a huge median home value, so people living there are probably more wealthy than people living somewhere else. And this runs down. So we take these things and we bin them into like the top 100, 101 to 250, 251 to 500, and then sort of everybody else. And then we can copy using the link capabilities on the zip code. So this U.S. top 100 on 10014 is copied over here to this person who lives in 10014. So here's the entity table, the zip for this person. He now gets his zip ranking. From an engagement bin, he's detached, or she. Here's the PITM, or the ID number, lives in New York, and you know, the CREF class is 2008, and this table would have the other stuff. So this is literally creating a new field in the entity table. You just basically drop these wealth by zip code levels in, and now you've got another potential capacity factor to work with. So it's really pretty easy to do this. And you know, in our world, we try to make this so that any Excel savvy analyst can add this kind of data and then push it out to a team. So I'm going through a little more detail here because this could be, we often see this as threatening, but it's actually really easy to do, and it's complements. And if we're doing work and we're trying to find the top prospects, which is the question, and a whole lot of people aren't well screened, we might want to look at this. So then synthesizing. The data comes in different levels of aggregation. I mean, for geography, you've got city, state, and country or county or whatever. So you may want to, in zip, you may want to like level it, and you may want to group things up or handle them in different ways or allow navigation from one level to another. Matching and binning. You're going to see two versions of this. One, matching, would be matching out on titles to find C-level experiences. Another one would be binning attachment or engagement scores into 5 bins. So instead of having a score that goes from 0 to 1 with a lot of 0.82, 0.84, you've got highly engaged, engaged, or whatever. Combinations, which is maybe you want to take 2 factors and add them together, numbers or strings. Model scores, you're going to see that. You can create mathematical scoring to rank people. And you can do this both within a table and across tables. So let's look at some examples. Here's examples of 3 cross-table calculations. You want to find numbers of sports played, because back to the question, we're trying to find levels of engagement or attachment. And then presumably if they played more sports, a model might pick up that, hey, that's helpful to describing who's more engaged and more likely to give. So we have an expression. You would just type in the entity table, link, numbers of sports played equals link on ID to the sports table on ID. Every row stick in a 1 and sum it. So what this is going to do is presumably Some people are in the sports table multiple times. Some people aren't in the sports table at all. And it's going to just sum how many sports participations they've had and put a new column in the entity table called numbers of sports played. And this is done in an app outside of the database. So for those of you who know, database query language, you can obviously do this in the database, but this is a sort of a sandbox environment where, again, anybody who can write Excel macros can write these kinds of things, and it's just not a hard expression. So now you have a factor in the entity table synthesized from the student sports or activities table that's got this number of sports played. Another one we talked about earlier is we wanted to know the numbers of the years out of the last 5 they made a gift. Similarly, that would equal link on ID to the gifts table on ID if the gift fiscal year is greater than or equal to the current fiscal year minus 5, and the gift fiscal year is less than the current, it's not the current fiscal year, then the gift fiscal year, else nothing, missing, and then unique count. So right now it's, I guess, 2018. So this would give you, back 5. So it would be 17, 16, 15, 14, and 13. So if there was a gift for the person on the ID in one of those years, it's going to flag the year, then it's going to do a unique count of the years. So what this is going to do is put 0, 1, 2, 3, 4, 5 in the entity table, because there weren't more than 5 years, and there could have been 5 or 4 or 3 or 2 or 1. Now you have this factor that is a recency of giving metric that could be used in a model. Not hard to do. C-level job is going to look a little more complicated. It's a little more complicated because the problem is the titles come in all kinds of different forms. So somebody look through the titles. So there's this first part. If you match out in the job title, which is the field in the employment table, president or CEO or chief or VP or chairman or partner or board or founder or owner or managing director or vice president, because sometimes it's spelled out, sometimes it's not, then yes, it's a C-level job. Else, if you find it in there at all, then no. So they're in the table, but they don't have a C-level job. And if it's neither of these, they're not in that table, so there's no employment data. So this creates 3 conditions: yes, no, no employment data. And you actually need this because no employment data is different than no. You really don't know. I mean, they could, but they don't. So you would be wrong if you threw this in with the no. So therefore, the 3rd condition. You'll see this in a minute. We're going to use it. This kind of work, this could be a much longer expression. If you look at our contact database here at Advisor, we don't have good, we have a lot of different job titles, and they're misspelled and everything. So yeah, if you write something like this, you kind of got to watch it, and then, hey, this one should have been a C-level job, and it was, instead of vice, it was VIC pres or something. So you got to okay, fine, we can match out on VIC. It picked up something that wasn't a C-level job. You could just adjust this thing over time. So, our kind of view here is get something up and out, and then adjust it, iterate it. And this is an example of an expression that could be built. You put it up and then iterate it. And each of these calculations adds a new column to the entity table. So if you did this, you'd now have numbers of sports played, numbers of the years, the last 5 they made a gift, C-level job. So went through this in a little bit of detail. But this idea of synthesizing the data so that you can use it constructively and turn data into information and content is actually not that hard. And it's a lot easier to do in a front-end sandbox like this than as SQL queries in the database. And this persists. If you do this in one of our projects, it saves, and every day you reload the data, all of this updates again and recalculates, and it's going to rerun all of this stuff. So maybe somebody just made a gift, so they went from 4 to 5 when you ran the data overnight. Couple more examples: model, scores, and groups. We're going to build an attachment score model, which will create a score on everybody from 0 to 1. We're going to go through the details on the next page, but this will throw a bunch of math in. I'm not going to go through the math. This is a little more complicated, but you don't have to write it. The software generates it. But you can basically see that committees in the last 10 years get some kind of a square root with a factor, then reunions gets some kind of a factor. It looks like more linear. Gifts in the last 5 years gets cubed with some factor, and then there's a square root of student activities minus something, and then so there's a bunch of math. Gifts last 6-10 years matter, and so it's taking the factors that are found to have influence on giving and writing them into an equation that weights them appropriately for your institution. And you'll see in a minute, when we do this or you do this, you do it with your institution, because in some cases, reunions is going to not be present. Here, reunions comes up pretty strongly. It depends on what the reunion program is. The same thing with student activities. It may depend on what they are in giving. So we see in industry, people take these generic industry scoring models and apply them to their situation, but your situation is nuanced, and I guarantee every one of you is going to have different weights in something like this. And they will change over time, and they're going to change as you get new content and want to put new factors in it. Like maybe when we ran this, we didn't have newsletter click-throughs, so it's not here. But we got them, loaded it in, accessed it, blended it, created some metrics, reran the model, now it appears. Well, this is something in our world where any Excel-savvy user analyst could update this model, and then you would see it. The newsletter click-throughs have a material impact compared with these other factors. So that's why we're really big on helping teams use the data that they have to do these kinds of things. Then attachment groups. So this is going to throw out a score from 0 to 1, like 0.83, 0.72, and most people in use cases, we find if you do that, they're going to debate whether it's a 0.72 or a 0.84. Why is one higher than the other? And they're actually statistically the same. So why not just put them in some bins? So if the thing's over 0.35, it's an owner. If it's 0.2 to 0.35, they're highly engaged. If it's 0.1 to 0.3, they're engaged. And if it's 0.025 to 0.1, they're disengaged, and otherwise they're completely disconnected. These cut points come from the data distribution, but the bins, and you'll see in a minute when we use one of these, users get it. And you probably at some point want the score detail and what the factors were for it. But we have seen so many teams get these complicated models, push the scores out, and people start debating the 0.73 versus the 0.84 versus, hey, the person's an owner. Like, let's get on. It's like the person's an owner who has never been visited and isn't even assigned, and the person's they live in a wealthy zip code. Like, let's meet with them. That's the issue. It's not like debate the score. It's like, here's a person that we should be doing something with. So I get kind of passionate about this because we really do believe this is doable by teams. Not that hard, and we're going to go build a model. So I'm going to build an attachment model. So to do that, first you got to ask a question: what causes some people to give at or above their capacity? Who else looks like that? That's a question because it's got a target. Some people give, and there's a base capacity. So that's a good question. So it defines what's the target, what's the base. Let's say the target is undergraduate alums who have given over $100,000, because our question was about undergraduate alums. And undergraduate alums probably behave different than law school alums or parents or friends, so we got to break the population apart. Then the base is all undergraduate alums rated 100,000 or plus. So you're trying to use data on interaction engagement to try to determine what makes the target different than everybody else in the base. And then a bunch of explanatory factors. We just worked on that through accessing and blending and synthesizing, things that indicate opt-in, expressed interest, committee participation, events, reunions, giving, newsletter, click, student, sports. And a caveat here is if somebody became a large donor and then got put on a committee, that's not a self-expression. That's an after the fact you did something. So you're trying to find here factors that are people expressing interest, and generally these things are. And then you build a model. In our model, we use regression. There's other modeling techniques, point and click. Need Excel skills, no stats degree, data prep. We did in the memory pool with the bidding and synthesizing. You test, iterate, explore. Models complete quickly. 20 seconds to 4 minutes to run one. So let's take a look at one. So here's an example of, I say the model is, as we said, we've dropped the population to everybody who's rated over $100,000, and then there's somebody put a bin in, so this is everybody's given 100 to 250, 250 to 500. So in our world, these are the bins of people who actually had the behavior of giving at or above $100,000. So you select the target by just sweeping with the mouse, and then you see that the target is the 1277 people who are in these bins, and the base is the 24,000 who are having a capacity of 100,000 or more. The rest were excluded. There was a filter got clicked like 2 pages earlier to do that. So now you're ready to go. So you click up here, build a new model out of this modeling panel, And the task view on the left, this is one of the things, build a model, pops this panel up. And then it gives you this page where you have to name the model. Attachment is a good name. Pick the table entity. You could do two kinds of models with us. One's a forecast, and one's what's called a classification. A classification is set membership. Here you're trying to do a set membership. You're trying to figure out what makes the people as a group who gave 100,000 or more different than the ones who didn't, even though they all had the same capacity. Forecast would be you're trying to forecast how much they might give. The challenge with forecasting large giving is it's a very skewed distribution, and forecasting doesn't do particularly well with that kind of distribution. But you could do both. You could do it this way, then do it the other way. Modeling people would kind of add into that. So then you have these explanatory factors. You just check off the ones you want: numbers of alumni committees, numbers of gifts in the last 5 years, reunions, sports, all those things we were talking about. Just factors. Check them. And you click down here, train model, and you've got it's sort of set to training subsets. So if you give it 2 million rows, it's going to start with 10,000, let you build it over time because the model will run quicker. And then you've got some p-values, which you can make the model more or less, say, accurate. It starts with the median value. You can step it up. That's about all the stats you need. So you click train model, and it runs. And we call this descriptive analytics. It describes what it found. There's some numbers over here that the model ran while it's green and gives you a number. But here are the influence factors on explaining that target, which are the attachment factors. Numbers of reunions explains almost 40% of it, followed by numbers of volunteer committees in the last 10 years, followed by numbers of alumni committee participation, followed by the numbers of student activities, followed by the numbers of the gifts in the last 5 years, followed by the gifts that should be 6 to 10 years back. So this is, if you're in this institution trying to build connection, you would focus on reunions and volunteer committees. They're right at the top. Maybe alumni committees. Those things are the three biggest. And the math that you saw in the prior equation is summarized here. It dropped that math in, and then it created some bins. And as a distribution, we would typically re-bin based on the distribution and kind of what makes some sense. So that's the output. And then let's see how you'd use this. So we've now access data, blended data, synthesized data, model data, and I'm going to go live and sort of go through a use case. So I'm opening up an advisor project on a server, it's opening in a browser. We run in browsers, tablets, iPhones, Windows desktops, probably enough. So this is a prospect list. So this is a list of it's like 93,000 people. It's got all the ratings. Everything's in. So we're going to come back to this. It's got, though, look at the top, Harley Oliver, ID number, lifetime giving, class year, alum, Mundelein, Illinois, staffed, C-level job. So this showed up here. Yeah, he's got a C-level job. This next one's got no employment data, 10 to 50 million rating, disengaged attachment. So here we're seeing the stuff we just calculated showing up in the entity table. Let's go to the next page. Look at the same group in terms of ratings. So we got the same 93,000 people. There was some research validated capacity. A bunch of people, though 38,000 don't have a rating. Let's take a 40% of this. And then there's a group red that's 50 million or more. This is now 10 to 50 million. It runs down to 25 to 50 million. There's a list of people, a summary list, and then here's the C-level job. It looks like 20% have a C-level job. This is a demo data off an elite institution, so that's not that surprising. There's a group that doesn't have employment data. It looks like 24%. This ought to be filled because you can get that off social media. It means this is less representative with a gap like that, but that's not a bad gap, and then the rest don't have or have not had a C-level job. So the question here is, let's say we want to find out, do we have any high-capacity, highly engaged people who are on staff, and where are they, and let's set up a meeting. So this is now pushing it out to the users. And we've been the attachment scores. Here's the owners, highly engaged. So this is what came out of those calculations. So to answer are there high-capacity, highly engaged people who are on staff, I would, let's say we want to grab these 5 bars. I just selected the people who are 500,000 to 1 million. This is a million, so we've got up to 50 million. This is the top groups, and that's 6,306 people. And I can sort of see when I select them, the color shows in here and disconnected. The brush up, there's 2,305 high capacity disconnected people. That's a lot. We might want to see who they are. That'd be another question. But they're only 4.7% of the disconnected. There's 1,408 up here who are highly engaged. The brush up out of 8428. So it's 17% of the highly engaged are high capacity, which is good. So I've got more of my high capacity make up more of my highly engaged. And let's look at the owners. At 26% of the owners. So presumably I'm cultivating these people, so they're getting more engaged, and so that's good. I'm seeing a skew there. So I'm about to do this, and somebody says, maybe my research director, as I'm planning this dinner, says, but maybe there's some C-level job people who we ought to be meeting with as you do this dinner, and I think we're going to Denver next week. So I could say, fine, let's add in. So I'm going to go put the mouse in add mode, add in all the C-level jobs. So now I'm up to 24,430 people. So I've got the high capacity people and the C-level jobs. And then we kind of talk about it. Well, we've already screened the C-level jobs who are in these rating categories. You can see the colors. So let's take them out because we only want the high capacity and the non-rated C-level jobs. So let's subtract out this group over here. This is showing you how these visual tools can be really flexible on how you go about exploring data in kind of a discovery fashion. Now I've got 10,000 roughly people who are high capacity, and it includes C-level jobs who were never rated. That's what I want. So let's get rid of the gray. And then out of this, I'm going to go back to replace. I want this group. I want the highly engaged owners out of this high capacity C-level jobs who weren't rated. So I grab this, get rid of everybody else. Now I've got 2,000 people who are this combination of high capacity C-level jobs who aren't rated, who are also highly engaged owners. And now let's look at, are they staffed? Those 2,000 people. Well, it looks like most of them are. Looks like 1,338 or 60% are staffed. The other group isn't. I can see by the color, the blue here are the unrated. So this blue are the people I picked up who were C-level jobs but never rated. I also see some of the unstaffed actually were rated and for some reason aren't staffed. So this is like the cream of my crop, and with the blue are people I want to explore. And from a staffing perspective, I'm trying to get, maybe 75 to 120. I've got maybe Megan up here's got a few, she's pushing the limits, 121 of this group. I can see, here's Dan Law. He's at, what's he at? He's at 69. He's got this bright red, so the color is helping me understand. He's got the really, really high capacity, highly engaged people. Great. So now we want the unstaffed ones. So I'm going to click this bar. Obviously, this goes away because they're not staffed. There's 679 people who are high capacity, C-level jobs, not rated, highly engaged owners who aren't staffed. I want to look at this group. Where do they live? So I'm going to go to the map and get rid of the gray. They're kind of all over the country, but I think my assistant said I'm going to Denver. So let's grab the Denver area. Get rid of everybody else. So now let's go back to this first page. I've now got a list of 22 people who meet my criteria who live in Denver. And I got, $38,000 donor, Dorotha, class of 74. She lives in Silverthorne, Colorado, not staffed, not a C-level job per my data. She's in the database of employment, but not a C-level job, 1 to 5 million, highly engaged. And I can sort of see down this. I mean, here's no employment data, but rated. Here's no rating, but the C-level job. I can sort of see in here where they all came from. This looks like a good group for my dinner. Now, using the modeling, we want to go back to the attachment score detail because we want the detail on these 22 people because we want to know how to cultivate them best. So I'm just, drilling through this group of 93,000, now trying to set up for this dinner using the data that we access, blended, and synthesized. And here's the scores that came out of the model. You can see how the bins came out. And I can see the factors that made up the scores. Numbers of volunteer committees in the last 10 years is really important. The ones at the top have a bunch of those. Most of them don't. They've been giving consistently the last 10 years. The people at the top have been less reunions. These people more reunions. Some sports. I can't actually change this. But as I'm looking at this dinner, I'm going to, here's some people on committees. Maybe I can use them, but none of them. Maybe I can seed some other people in my top committee participant donors who maybe chair these committees and get them in, and maybe try to get some of these other people on a committee. I mean, I'm starting to strategize about my dinner. And then somebody says, well, what affiliation? So the 22 people, here's class years. There's a bunch of 50s. There's some 70s in here, and you can see the purple of the C-level jobs that weren't rated. The others are the rateds. A bunch of the 70s and 80s, alums, spouses, parents, multiple schools. I can play around with this. Any patterns in sports and activities? Yeah, skiing. There looks like there's 2 skiers. Fraternity, sorority. Let's drill down on that. Drill down the details. 2 fire and breath. So maybe there's some relational stuff I can do here. And last, let's just check out giving history. What are these people given? They're all rated $500,000 up, or have C-level jobs, and they're all engaged. So my biggest donor was only $38,000. I can see the buckets here. Let's just check out, like, how about Creola Clevenger? Creola is given $34,000, sort of $2,000 a year, some downtime, and back in the early 2000s, up a bit recently. $2,000 a year. What's her rating? Let's look at the color for this. She's 5 to 10 million. She's highly engaged owner. Yeah, this is just getting a story here. Like, she should be stepping way up, and we can go back to the first page and whatnot. So that's the idea here. We've taken this data, we put it in a form, we pushed it out to the team, and we started to have discussions using it. And as we just look at this, we really feel that this kind of work is best done with the team in-house, because you know the data, and as you build models, you know those different factors. You can talk about whether they're actually causal or not. We like the idea of just trying something, learning and adjusting. We will say like a model now is better than a more complicated model later. Just get the stuff up and iterate it. Don't overcomplicate it. You've got more good data than you think. And even if you just have giving and some event data, you can get started, and then you can get click-throughs and employment and the other stuff, and there's a variety of ways of getting them over time. And keep it dynamic. Update as you acquire more data. Like that modeling score is not set in stone. It's going to evolve. You can make it better when you get more data and more factors to put into it. And then in terms of driving results, we're actually doing a survey for the Drive conference in a couple of weeks on this, and we're finding that what often happens is the data is not used by the team, and the senior management doesn't get behind it. So you actually got to use it and have discussions around it so that people on the team see that, hey, this data can actually help me make better decisions, make more money faster, help the annual fund, all of that, and let it call out stories and discussions. Just that kind of dialogue I monoplayed, but that's kind of, yeah, we're looking at it and say, well, could there be some C-level job people who aren't rated who we might want to throw in this dinner as well? That kind of stuff. Adjust as people react. Like if you start throwing scores out and people are debating the scores, group them, bin them, do something different with them so they're not, you don't want the data debated. You want the data to draw out stories, and then use it, as we say, to build a culture of analytics. And when these things happen, we've seen teams transformed by using the data every day in annual giving, major giving, field officer management, all the things that you can do with it. So we're really encouraged by that, and ultimately the goal is you raise more money faster. That's the end result of all of this. So just what we just went through was a lot, and I went down into some sort of very detailed authoring just to show the capability, but and to make it clear that this is Excel savvy, and it's like writing macros in Excel, and it doesn't have to be a threatening thing. But the idea here is frame the question. Start with what you're trying to answer, why you can't address it today, and then think through what might help you answer it. Then access the data, and here's again an example of pulling from a variety of places, blend it, synthesize it. Went through some great examples there of how to create factors that could be then used in a model, or how to parse out things from text things and make it much more useful than just lists. Modeling can work well. Keep them simple. Push it out to the team, and then use it to make decisions. So that's what we've covered. Said I'd do it in 30 to 45 minutes. It looks like we're right at 45 minutes and have time for some questions. So you can put questions in by typing them in at the bottom right of the GoToWebinar panel, or you can raise your hand if you're brave, and we can unmute you. You can ask it live. Usually people type the questions in. Well, here's a question. What are the skill sets for somebody to author in this and then use this? So a lot of that, let me just back up. Typically authors are going to run the access blending synthesize model and probably pushing it out because they're going to put it somewhere to go out. So the people that do this, need to be inquisitive. They need to be able to understand causality relationships. They need to be Excel savvy. You got to be able to write macros, equations to actually get the data to be synthesized. They don't need stats skills. They need to, though, be understand back again causality and be able to be intuitive to think through hypotheses and effects. That kind of person is great, and often they could be people on the prospect research team. The annual giving team usually has people like that. They don't need to be math people. We actually have a history major who's awesome at this. She's just smart, savvy, and she's inquisitive and can understand relationships. And then pushing it out, it's pretty easy to push out. You create one of these, we call them projects. They can be hosted and run out. They can be published to a server internally. But the publishing process, back at the beginning when we accessed data, there was a set of tasks, and at the bottom was share results. It's just literally, you can click that and then publish the result to a server, which we would set up or your IT could set up, or it could be hosted. When you publish it, it then returns a URL that can then be emailed out or posted on a SharePoint portal, and it has security and all that embedded in it. So it's all of that. But it's pretty easy once you've done this to set this up so other team members can get it. The other team members are people who want to explore data, and the project I went through would be for prospect research teams. And they may not be the ones that would do this, but they can run through this scenario I ran through and understand, hey, this is smaller than I thought, or what's this group, or why don't we take a look at the C-level jobs and see what it might do. Annual giving staff the same way, and it's often cutting lists for this or that. Field officers in management, what I just showed would be too complicated. You would have a project with fewer pages, fewer charts, much simpler, more of a typical dashboard. So the part of it's getting the balance, right, for the users group when you push it out. So, but these are people who just need to consume information and want some simple way to get at data and to do, queries, and without having to go back to the database. In fact, there's another question that's sort of related to this. The query question, I'm going to paraphrase it. We solve what we call, with this kind of stuff, the cycle of pain. So what I did with finding that group for that dinner and being able to understand it, it can be done in a database if somebody knows how to do it, but it's a bunch of queries that take time, and there's usually a bottleneck. So we call that the cycle of pain, where you kind of know you want a group like this for this dinner, but you can't actually get it real easily. So you go back to whoever has those skills, and they come back with the list a week later because it's a backlog, and it's 3 people because the question wasn't interpreted the same way, or the data was different than you thought. So then you got to go reframe it and go back again. And so that query approach off of a data warehouse or a reporting tool is hard. We actually have all the data resident in memory, so when you're actually clicking on the charts, you're actually spinning around all of those tables we saw that were loaded up front. And you've got the full content all the way down to the giving records, the addresses, everything you want, all there. So it's literally that speed of thought, sub-second response time, and you can go forward, back up, and come at it again. So that's if you think of this concept of the cycle of pain and killing it with this speed of thought, very enabled environment, that's what this enables. And that's why you can push this out, and you can have people that in the past would be coming in with these requests are now self-service. And actually, there's actually one of our clients just came in to remind me. We have a client, which we can send you the data on. We can share it publicly, who, when they pushed out in the self-service mode, the ad hoc requests on advancement services dropped by like 85%. So they actually have a curve, a chart showing this. And it was because the team could then answer all these common query requests that previously had required somebody in advancement services to prep the data and push it out in a report. And that enabled their team to go off and do more strategic things. And they would say that was total cycle of pain relief. So that's the beauty of when you get the balance right here, Excel savvy people mucking around, playing with this analytics sandbox kind of a mindset. Then when you get something, pushing it out to the team so that they self-service, it not only makes their decision-making faster, but it also frees up this kind of custom report load on advancement services or IT. Okay, I have two technical questions regarding modeling. Is it possible to divide the data set in training, validation, and testing? Yeah, so let's go back up. Good question. So the question is about dividing the training set. When I described this model, we created a base population out of the generic group of 100,000 or more, and it was like, back up one, it was like this 24,000. So we parsed the data set into a target and a base, and let the model run across the whole thing. The model looked at and said, hey, there's a total of 26,000 rows in here. So it set itself down to a 10,000 training subset. So it picked 38% of it. So we have rules in here because if sometimes there might be 1 million rows, and that could take 3 hours to run. So we want completion times of 3 to 4 minutes. So the software will set a training subset, so it only runs through 10,000 rows to get the math working. So that's how we do that. You can adjust this, so you can set this slider anywhere from something smaller all the way up to the top. So typically, a more accurate model would have all 26,000 rows run or all 300,000 rows run. It's just going to take longer. Although statistically the variance between 10,000 rows and 500,000 rows is minimal. But you would want to do that if you're trying to finalize a model and play around with it at 10,000 rows. You're getting 2 minutes, 1 minute, 30-second response time on completions. And then once you get something you think is good, push this up so your training subset grows. So building models, the question about training subsets, we take this very seriously, and we're trying to balance, accuracy, which is more, versus speed, which is less. And 10,000 is the threshold we would set if the population was greater than that. Obviously, if it's less than that, it'll drop to how many there are. Then when it scores, though, so it might train on 10,000, but it will score everything. So the math will then get executed across the entire population of the 26,000, or you could open it up and score the whole 93,000 in this example. That's definable. But the concept here is smaller training subset, model runs quick, maybe then boost it as you get towards completion, but we're scoring as much as you want every time. And then this related question is this p-value is set at 0.01, which that's determining how many factors will end up in your equation. And we set that at, as you make it a bigger number, more will come through. You make it a smaller number, less gets through. And there's a bunch of stats why you might want it bigger or smaller. But we start with a moderate value, which lets the model run fast and gives you good accuracy. You can then adjust this also up or down on subsequent model runs and just look at what happens. Then there's another question. If I have a new feature, a new variable, and I want to add it to the model, is it possible to build it or build lift or ROC charts to compare the models? A couple of points in there. Thanks for the good questions. If you added more factors to the table, they're going to show up here. So these factors are factors in the entity table. And so if you were to add more, it's sorting them alphabetically. Suppose you put something, pound, I don't know, whatever up here. It's going to show up here the next time you load the data. You have another factor you could put in the model. So then you could run with maybe it's newsletter click-throughs or it's something else. Or you could just next run you might want to click one of these other things. It'll then do one of two things. It'll modify the current model and replace the old model with the new model. Or you can create a whole new model. So this, actually up here you can see some of the controls. You can edit the current model, which will save it over the original model, or you can build a new model which will save the first model, and then you have a second model with the additional factors in it. And in that case, obviously the coefficients and all the stats and the scoring would be, you'd have the original one and the new one with the new factors. I think that answered the question. Down to a couple of minutes here. The question of how many factors can you handle in the modeling? Good questions in the modeling. We use algorithms from a firm called Rapid Insights. I think many of you know that, who know us. And so this is their analytics product embedded in us with our controls around it and connected to the data in our memory pool. We have benchmarked against R, and we stack up really well in terms of quality of output, in terms of speed of completion. If you look at a curve of how many rows are in the table we're modeling against, one of us will be a little bit faster at one level and one will beat the other a little, but say we're comparable. And our response times, with the 10,000 training subset are going to be, we're going to turn the model around in 30 seconds to 4 or 5 minutes, even with like 1 million, 2 million row data sets. If you push up to 1 million or 2 million rows, it depends on how many fields there are that we're looking at, but that could take a couple of hours. So you're going to get long model runs, but we actually beat R on a bunch of those tests as well. Then the fields, we have done test bases where we will have 100, 150 fields in a model with hundreds of thousands of rows, and we complete. We actually don't recommend that. Generally, you end up with overfitting, or you end up with it's too fragmented. So generally, a good model is going to have 10, 25, 25, 30 explanatory factors in it. If you start building a model with 150, 300 factors, which some of these tables have, it's hard to differentiate. And that gets into the statistics on the p-value setting. But we will run fine with a table with 200 factors. You could click them all off. And we're pretty smart about figuring out, like, some things we can, like here's when we can't model a date. We will, things that are obviously we can mathematically determine related to the target. Like if you picked giving and giving was one of the variables, we would rule it out. So we do a lot of smart things here. So I guess that's a long-winded way of saying, from a capacity standpoint, we run with basically any data set anybody in this sector is going to have, and we try to optimize it so it's efficient and you can get learnings and then build on there. Good questions. I see we're right at the 2 o'clock Eastern time. Yeah, I'm sensitive to running over with everybody. I will say, if you want to keep the discussion going, got my email, phone number. We love doing this stuff. We will have this posted and out to you all within the week. And I hopefully shared some helpful tips today in one of our longer webinars, but we went through a lot of kind of grist on this whole steps of accessing, blending, synthesizing, modeling, and pushing out, because I wanted to show you and alleviate some of the concern we often hear that this is just hard for an internal team to do. It's actually not. And again, inquisitive, Excel savvy people in prospect research, advancement services, annual giving are doing this all the time. And I think we've taken the software down to the point where it's pretty doable. So that's our story. Thanks for your time, and have a good rest of the afternoon.